Alright everyone, welcome to section 5.1. Now this is going to make a little bit more sense. It's a little more practical as we deal with probability. Okay, it's going to be a little more practical for our use. Probably make a little more sense to you than some of the stuff we have been doing. Alright, so what's the probability of something happening? Well, in basic terms, that's the number of ways it can occur over the number of possible outcomes. Okay, so you want the number of ways you can do something over the number of ways you can and can't. So that would be the total outcomes there. Alright, so for instance, we have here a problem that says a report, as reported by the World Almanac, the top 5 state officials in Oklahoma are shown in the table to the left over here. Suppose we take a simple random sample without replacement of 2 officials from the 5. Find these probabilities below. Okay, so we're taking a sample of 2 from the 5 without replacement, meaning we can't have GL and LG. Okay, those will not be together. So how many different outcomes can we have? That's the first question you need to ask yourself. Well, I know since I'm selecting 2, I can have a GL, I can have a GS, I can have a GA, I can have a GT. Okay, I can also have a LS because LG would be repeated, remember. I can have an LA, I can have an LT, I can also have an SA and an ST and an AT. So if you count all those up together, that's 4 and 3 and 3, so that's 10. So we have, for this particular set, we have 10 outcomes that we can use. Okay, 10 outcomes. Now, letter A asks us to find the probability that we have a governor and a treasurer. Well, a governor and a treasurer. That we obtain the governor and the treasurer. Well, the only one where we obtain the governor and the treasurer is right here. That's the only one because it's not repeated, so we can't get it's without replacement, so we can't get a TG. So GT is the only one we have. So our probability of GT is what we want, and there's only one of them. We only have one of the governor and treasurer over the total number of outcomes, which is 10. Which is 0.1. Okay, so our probability here would be 0.1, or we could even say 10%. We could even say 10%. Okay, well, what about B? Find the probability that the Attorney General is present. Well, let's select a different color here. What about the Attorney General? How many of these have an Attorney General present? Well, we have an Attorney General present here. We have one here. We have one here. And we have one here. So that's 4 places where we have the Attorney General present. So the probability that we do have an Attorney General is 4 out of 10, which is 0.4 or 40%. Okay, which is 0.4 or 40%. So this is your basic probability. Find out the total number of outcomes you have, and then you can go about finding the probability of what you want, just like we did here. Okay, so let's look at another example. And for this example, it says the U.S. Census Bureau compiles data on family income and publishes its findings in the current population reports. Table 5.3, which is the one to the left, gives a frequency distribution of annual income for U.S. families. A U.S. family is selected at random, meaning that each family is equally likely to be the one obtained. Determine the probability that the family selected has the following incomes. Okay, so now we have, in this particular problem, you have been given the total. So that's the total outcomes right there. Okay, so they were nice to us. You don't have to figure that out. And because they gave it to us in frequency, they actually helped us with what we need, with the top part of our fraction, with the outcomes we're looking for. So they've actually helped us with that as well. So letter A, let's look at letter A. And letter A says between 50 and 74,999 inclusive, meaning greater than or equal to 50 but less than or equal to 74. So look at our greater than or equal to 50 would start here, and less than or equal to 74 would be there as well. So what you're looking for is, we know for this probability is that we know our total outcomes. Our total outcomes are 77,418. Well, how many are in the range of 50 to 74,999? Well, if you look up there, that's 15,754. So they've done that for us, as I said. So 15,754, which when you do the division gives you a 0.203 probability. So what's this saying? Well, this is basically saying, how do we interpret this? If I asked you on test how to interpret it, well, how do we interpret this? Well, 20.3% of families in the U.S. have annual incomes between these numbers, okay? 20.3% have annual incomes between these numbers. Let's look at letter B. Between 15 and 49,9 inclusive. So here's 49,9 and 15 starts right here. So we're wanting all the numbers in here, okay? Now our total outcome stays the same because we still have all these outcomes here. That's not changing. That's the total that you're given here. Now the partial, because you've got to think of probability as partial over total, what you want over the total, okay? Well, what we want covers those three ranges there, 15 to 24, 25 to 34, 35 to 49. So when you get ready to do what you want, you have to add 7765. Let's go back, and hopefully it's going to work here. Yeah, there we go. Alright. So 7765 plus we have 8296. So 8296 plus 11301. Now these make up all of the things that you want, your partial over your total, okay? These are your outcomes that you want between 15 and 49. So add those together, add those together, and you should get 27,362 all over 77,418. And when you do the division there, that's going to give you 0.353, which basically, if you were interpreting this, would tell you that 35.3% of the people fall into this category, the 15 to 49,999 category. Alright, well, pause the video and see if you can do letter C on your own. And then start the video and you'll be able to see my explanation of it. So again, the total is not changing. But how many do we have under 25? Well, under 25 would be these first two right here. 24,999 and under. So you've only got two values there that are under 25. You've got the 69.45 and you've got the 77.65. Which when you add those two together and divide by 77,418, you should get 0.190, which means 19% of families in the U.S. fall in this income bracket. So that can kind of give you an idea of how to do these probability problems, how I could give it to you. Now, you've got to realize, folks, okay, as you're going through homework, there are an infinite number of ways to give these problems. So you've got to apply what you're given, what you know how to do. Probabilities, partial over total, what the outcomes you want over the total outcomes. So keep that in mind as you're going through this. No matter what kind of chart I have, no matter what kind of word problem I have, it all boils down to the basics with probability. So keep that in mind so that if I give you a different kind, it doesn't throw you off, okay? So keep that in mind. Alright, so let's look at another one. Alright, so when the dice problems and card problems are really popular among statistics problems, especially with probability. So when two balanced dice are rolled, you get 36 outcomes, and here are the 36 outcomes you're going to get, okay? So find the probability that the sum is 11. Well, let's get our trusty pencil up, and so we want to find the probability that the sum is 11, the sum of the two dice. Well, as you can see here, we have 1 and 1 is 2, 2 and 1 is 3, and so on. So you're going to have to add these up. So we want the sum to be 11. So that's going to be where it's 6 and 5, and 5 and 6. So those are the two areas where the sum is 11. So 2 out of 36, or 1 out of 18, however you want to write it. And then divide that out. And so that's going to be 0.056, or 5.6%, okay, or 5.6%. Well, let's look at letter B. I would pause the video right now and see if you could do letter B on your own, and then you could watch my explanation. But letter B are the doubles. So when it comes to doubles, and let's switch to a different color so you can see this. When it comes to doubles, if you're not familiar with dice, these are doubles, okay? These are doubles when they come up to be the same, okay? So if each dice has 6 numbers on it, 1 through 6, then how many different sets of doubles can we have? It should be kind of obvious to you that we should have 6 sets of doubles. So that's going to be 6 out of 36, or 1 out of 6, which is going to be 0.167, or 16.7% will have doubles, okay? So you may have to write out, with dice, with cards, you may have to write out all the outcomes. That's quite a familiar process, writing out the outcomes. And you may ask, well, how can I write out outcomes with a dice? Well, look, this could be 6-1, and this could be 5-1. If you're wanting to write it out, if you don't have the nice little picture that I have here, you can write it out like that, and for all of these, and so these represent your dice here, okay? So you got to open your mind to different things in terms of how to being able to visualize all the outcomes. Because if you know all of them, all the outcomes, then you'll be able to find what you want and give me the probability just like we have here, okay? Alright, so now the meaning of probability, and you've heard me say this a lot, probability is basically a concept of percentage. You heard me change a lot of those verbally into percentages, And I'm okay if you write it as a percentage, and sometimes on MyLabs Plus it will ask you for the decimal, sometimes it will ask you for the percent, so be careful with that. But probability is basically a percentage. So how do we interpret that? Well, 0.314 is the same thing as 31.4%. So for this particular problem, the probability is that 31.4% that the gestation period of a woman will exceed 9 months. Okay, so now a probability near 0 is not going to occur. That's when we say it's an impossible event. Probability near 1 is when it's likely to occur. That's 100% possibility is what a probability near 1 represents. Now, this is something called the frequentist interpretation of probability, and basically it says that we know that if you're tossing a coin, you have a 50% chance of it landing on heads or tails. We all know that, just basic common sense. But what the frequentist approach says is no matter how many times you toss it, when you start tossing a large number of times, it's going to get closer and closer to that 50% mark in terms of your results. And this shows what I mean. Okay, these are two computer simulations of tossing a balanced coin 100 times, and you see as we get closer to 100, we get closer and closer to that 50% mark in terms of the number of times we're tossing it, in terms of what we're coming out with, okay, in terms of the heads versus tails. So we get closer and closer the more we increase. So that should kind of make sense to you in terms of it should reinforce and assure what you already know, okay? Now we have some basic properties, okay, and these are kind of common sense with what you know. Probability is always going to occur between 0 and 1. So it's always going to either be 0% chance, between 0% chance and 100% chance. That should be kind of common sense to you. And I've already discussed the last two. 0 means it's impossible, and 3 means it's a certain event. Property 3. A probability of 1 means it's a certain event. So let's look at this example we have down here. And what we have is this. We have our dice example again, and what we want to know is where is the sum 1? Well, look at all these. 1 and 1 is 2. Well, first of all, what's the smallest sum we have up here? Well, you don't have a 0 dot on a dice. It's just 1 through 6. So if we're rolling a pair of them, the smallest number we can have is 2. Right there it is. That's the smallest number we could have is 2. So the sum of a dice is 1 does not occur. So that's a 0 out of 36 chance, which is 0. So that is an impossible event is what we would say. We would say that that is an impossible event. Alright, well let's look at the second one. Letter B. The sum is 12 or less. Well, think about what's the most that one of these can be. Well, since they both have 6 on them, 6 is the largest number on both dice. Then 12 down here at the bottom right corner would be the largest number that you could get. So everything, all the other ones are going to be less than 12. So this would be 36 out of 36, or 1, or as we said in terms of percentages, a 100% chance, which we would say is a certain event. It's going to happen. Okay, it's basically what that says. Now this is section 5.1. Hopefully you've enjoyed it. Hopefully it's been informative to you. Work those examples, and 5.2 and 5.3 will be coming shortly. Thank you.